Hello, everybody. Welcome to the coffee morning. So today we're doing AI systems for the majority of the day. So this is usually a 2 hour course, but we're going to go through it quite quickly because I don't think it's as dense as needs to be for 2 hours. But what we're going to talk about is the AI system in introduction to navigation. So this is sort of this would be our first course before we teach about behavior trees and state machines. And this is just simply how to when we are telling an AI to go to a certain location, how does it figure out how to go there? So let's jump in. Um, we're going to set up, what we're going to do in this is we're going to look at the nav mesh and we're going to configure some custom nav mesh options. And we're going to, we'll probably have a look at the nav mesh invoker, and we'll have a look at avoidance a bit. Now, there are some example packs that you might want to look at. The Robo Recall mod pack is a great example of conventional level design that you can bring out. So what it has on it is it's a VR game with robots, but it has a city which is relatively sort of low poly and everything because it's VR, very well optimized. But it's got a conventional nav mesh in it with things like nav mesh proxies. Again, Lyra is our example pack for what is a AAA game or the basis of a AAA game with good programming, including some really great AI in it. And finally, there's the Matrix City demo that make sure you've got 100 gig on your hard drive if you want to download this. But the one thing that this does incredibly well is crowds. It's just jam-packed full of people wandering around the city. And if you ever want an example of how crowds can function to pick apart, the Matrix City demo is very good. Okay, so I'm just going to be running with the top down. I have no expectations of you guys. You can follow along if you want, but this isn't an exercise. This is just me going, this is this, this is this. So it might be a better one to just watch in this case. It is. So what I'm going to do is I'm going to jump into the engine at this point. It should be hiding. Okay, so here I am in the third person template. And if I was to, I'm going to make a very quick AI. So I will just, I'm just going to create a pawn. Actually, I may have an AI in here that I can just use. So let me delete, let me just see if I've got a pawn. Simple AI. That guy looks good. There you go. Okay, so I got a AI in here. Now, if I kick off on play, poor guy cannot do anything. He just stands there. And that is because we have no nav mesh. Now, how to get a nav mesh into our scene is, again, we've just got the quickly add to our project at the top here. If I search for nav, you'll see we have an actor called a nav mesh bounds volume. And if I add that and press G so I can see it, nav mesh bounds volume. I cannot see our nav mesh bounds volume.
It doesn't play. You're in play.
Oh, good point. Yes. Okay, so this scene actually does already have a nav mesh bounds volume by the looks of it. I think I've added one in later, but I'll delete this just so that we can go from scratch again. So At the moment, he doesn't move because we don't have a NavMesh bounds volume, or I haven't given him instructions by the looks of this. So what I'm going to do is I'm going to jump in and create a NavMesh. So under NavMesh bounds volume, you can see that we have our cube. I'm going to drag it over and press N so it sticks to the floor. Drag it back. Now, in order for this to generate a NavMesh, I need to increase the size and map it out like this. Now, this is going to generate a NavMesh inside of the volume. So if I only have done it for half of the size, for example, and I press, I can visualize the NavMesh by pressing the button P. And what's interesting is there seems to be a second NavMesh. Looks like there's a second NavMesh in here. I've got the recast bound. Let's delete this guy. Must be called something apart from the NavMesh. So if I delete this still, we should have no NavMesh, but we do have a NavMesh, obviously. I picked a rather weird level to I'm going to start a new level just to make sure we've got something clean. Don't save. So if I press P, we have no NavMesh. So now if I add in a NavMesh and press N to stick to the floor and drag this out and press P, you can see that we have our NavMesh. Our incredibly simple, straightforward navigation. Let's see if this AI works. No, I don't think it has any AI functionality. So I'm just going to add in a simple AI. Nope. Let's see if I can find simple AI. Oh, no, it's not in here. Okay, right. So what I will do is I'm going to grab my test AI. And you can see we're missing a component called simple AI. Let me see if I can grab that and drag that in. So 1 second, just search for simple AI, EU asset, also backup. That would probably do. Open path. In simple AI, sorry, I'm just loading in a file so I don't have to build the AI out from scratch. Show in Explorer. Simple AI, the first. Okay. Add simple AI. Compile. Simple AI. I'm just going to event. Get rid of these two, I think. That. Files. It's not going anywhere. Wander. Control points. Chase. Right, I'm going to rip that out. I'm sorry, faffing around. Access none when drawn, so that should be fine. I'm just going to delete that quickly. And so the most basic thing you can do with an AI is get random reachable point in radius. Get actor location, radius 10,000. AI move to location or actor. On move finished, lay 6 seconds. Okay, so this is the simplest way that you can make an AI. So all this is doing, but it's just for demonstration purposes, is when it begins, we're looking through the nav mesh for a reachable point in a ridiculously large radius. I'm going to reduce that down so we see it. It's then going to tell the AI to move to that. And on move finish, it's going to wait half a second, and then it's going to do it again. So, controller. Get AI. Get controller. Get AI controller. Okay. Compile. And yet my man does nothing. What have I done wrong there? Oh, I'm glad we're recording this. So, okay, that should work. Okay, I'm going to just selected object, simulate, get AI controller. Maybe I need a reference to self. Controller, that seems fine. Okay. Yes, here we go. Okay, so we have our AI moving. Okay, so we have.
What was the issue, Edward?
So my issue was connection. So the first thing was a simplified AI system that I haven't finished. I thought would be a quick way to get through it, but I need to work on that. But this is I needed to give it a controller, but the get AI controller, I usually presumed, like you can see here, like if I go get actor location, it will automatically pre-populate the target with self, where the AI controller does not seem to do the same thing. I just presumed it did. So I have to tell it that it's the AI controller of this actor.
Okay, understood. Thank you.
So was there another question there, or we good? Okay, so let's go through. So we have an AI that we can now play with. Elena.
Yes, hello, good morning. I was wondering if this AI system can implement to another character. Should we put the same animations of man and queen to do the same with another character? How is the process of putting another character in AI? Do something like this.
Well, you know the work that we've done with changing the character over for the player character. It's exactly the same thing. The only difference between this and the player character is this is going to be controlled by AI. So everything that we've done on changing the main character over and using a different mesh can be done exactly the same way on the AI. So it has jumps, it has an animation class, it has a skeletal mesh. The literal only difference is that in one we have a player controller and one we have an AI controller. And so AI is denoting the actions it should take. And in this case, this is the simplest form of AI, which is a logic based, where we're just writing the logic as we go. The other types that we're looking at are behavior trees and state machines. So they'll take over how the actor works. So Danielle, you had a question?
Yeah. Could you please repeat again? Is this blueprint is a part of like AI character, or it's a separate entity like AI blueprint that we're sticking into, I don't know, any actor that should?
So this is effectively a character. So if I wanted to,
so this blueprint is just a part of. Okay, got it.
yes.
I was seeing test AI. I thought maybe it's like something similar and separate entity.
Oh no, it's just
do we need it to be a pawn or a character, or is it possible to stick it into an actor?
Okay, so that's a good question, and it comes down from what you inherit as a character. So the reason I'm using the character as a base is because it has the character movement, which is functionality that can tell things to move somewhere. If you were to do it as a pawn as a base, it would still work because a pawn has the ability to take a controller. What it might do is it might have problems moving somewhere. Because if I tell a pawn to go to a location, it's going to go how? If I don't have the functionality that's connected to it. So this is why, if you remember when we were talking about how the classes inherit, I will usually start from the character class because the character class has the movement component attached to it, which allows it to move to a location. Where you could definitely start from a character class, but you're going to need to implement some movement code in order for it to function, to do something. So a pawn is your base class because your pawn is what allows it to be controlled. So a pawn means it can be controlled by an AI controller or a human controller. Does that make sense?
Probably, yes. I'm thinking so. In my case, with my graduation project, it feels that I need to create a pawn. I don't need it to be a character, a full-scaled character, because like I don't need that much of animations. But probably, yeah, it kind of makes sense.
It's not the animations that is the main thing. The animations is useful, but it's the movement. Because are you planning to get your AIs to move?
Yeah, this mimic monster I'm hoping to do today, it should move randomly, and as soon as it's possible to reach player, start reaching player. So probably, yeah, it will be a character then with a movement. Okay,
cool.
Kind of. Okay, thanks.
Gonna let somebody in. Yeah, so I would probably start from the character point just because simply you've got the ability to tell it to move somewhere. But again, this is literally just a character. So as you can see, the parent class here is a character, and I can delete any of this code. None of this is needed. So everything that we've been working on, there is some stuff I made about changing the color and stuff like that, but you'll see that in the other project where it's just so that we can see what's going on. Eleanor, did I answer your question, by the way? I feel like I might cut you off there. Okay.
Yes, thank you. Yes.
Okay, cool.
Thank you.
I'll carry on then. So, okay, so we have our nav mesh and we have our character, which is moving around. So you might note there's something called a recast nav mesh default. So this is a sort of manager for the nav mesh, and it will automatically be created at the point that you create the nav mesh. Selecting view modes. Okay. So let's have a quick look at some useful. I'm going to add in some shapes just so that we can see how this nav mesh works. So as soon as I create a shape, you can see that the nav mesh is updating to see how it sort of works. So as you can see here, I've now got, if I create this high enough, it's sort of blocked. And if I drag this around, you can now see that it can walk around these different elements. So that the character is now going to move around these, and it's going to try and predict the shortest path for the nav mesh as it is moving. There are a couple of useful view modes, but we can probably jump those. It's only useful if you're actually within if you're going to be optimizing this. But let's start off by let's add something in called Daniel, you had a question?
Yes, apologies. I have another question, right, about nav mesh generation. So is it generated only in editor, or because I have constantly changing landscape and I already created it, will it be regenerated every single time I'm shifting parts of labyrinth, or it will be regenerated only in editor, and as soon as I launch the game, it will be like it won't update?
Well, that's a good one. So a couple of things. Firstly, you've got something that's called, and I'll come on to it, but you've got two options there. You can either basically make your nav mesh dynamic so that it updates, and then you can change the frequency that it updates. So that is a setting within the nav mesh. And the other thing you can do is you can tie a nav mesh to a pawn. So you have an actor that's part of a pawn, and it will generate the nav mesh around the pawn as they move. So you don't have to so if you've got a massive world, you don't have to have a nav mesh, which is absolutely incredible, especially if it's randomly generated. You probably only want a small nav mesh created around a pawn as you're creating it. So you have options. I'll go over them as they're going. Eric, did you have a question?
Yes. So that works perfect with plain terrains. What happens when the terrain is more steep, or you know where I'm going, if they need to climb?
Okay, so, well, we have some settings. The first one is your step up value. You know what? I think I'll go off that one and get to it. So the first,
Okay,
because if we look at the settings, I'll just try and go in these in order, and I'll sort of demonstrate how you go about sort of what options we have available out of the tin. So, okay. Nav mesh modifiers. So you had a pond that you didn't want people to walk over, but it was an option. We have something that's called a nav mesh modifier volume. And if I create this and I drag this and place it into our nav mesh, you can see by default, it's going to basically just block the nav mesh. So if we didn't want people to walk through here because it was an electric fence or something that hurts them, then we can place that in, and then the character's going to, if they're trying to get to the other side, they will go all the way around. So as you can see, they're coming around here. Now, you can change the values on a nav mesh proxy nav mesh modifier volume. And so you can make it so that it's not completely, like at the moment it's set to block, but what we can do is we can have it, so you can see under the area classes here, we've got the default, which will block it. We've got low height, which will trigger crawling if your character is set up to control. So, or we have obstacle. And when you create an obstacle, you can see that if I was to place the obstacles around the character, it's not going to stop them going through it, but they would attempt to avoid it dependent on the cost value. So if I come into I've forgotten where we get the cost from. I'll just increase the size of this. Shared volume opacity value. So let me just try and find cost or. So you can, I've forgotten how, you might have to create a default of it, but hollow, polygon, lifespan. Yeah, I'll look that up if anybody needs it, but basically you can, by default, it just makes it, I think, something like twice the cost, and they'll do their utmost to avoid it. So you can see in this case, this character will run around it rather than go through it. But we have options for nav mesh bounds so that we can manually edit our nav meshes. Okay, so the next element is something called nav mesh proxies. Now, when you're working with a nav mesh proxy, say you want these characters to be able to drop off of the top here. So if I grab my character and place them on the top of this nav mesh, I'm going to reduce it in size. Maybe a bit more. Now, there is a strong chance we want that character to be able to, ideally, we'd like that character to be able to jump down off of the nav mesh. Now, at the moment, they can't. If I run it, he's just going to move in little small circles because that's all he's got within his reachable, navigatable value. However, if I wanted them to drop down, I need to create a new blueprint class. And if I search for what I want is, I'm going to search for a proxy. And you can see that we had something that's called a nav link proxy. And what this will do as an actor, as I drag it in, you can see that I have two of these little gems that I can move around. And if I drag this up and plug that into the next navigation, you can see there's suddenly a dark blue line which appears. And what this means is this point is connected to this point in a navigation. You can go from there to there. But if we look in the settings here, you'll see that there is an option for link direction. And the moment it's set to both ways. So it thinks it can get from there to there and from there to there. However, it can only actually get from left to right. I'm going to change this from left to right. Now the arrow doesn't have an arrow point. It's a bit hard to see, but it won't have an arrow point on the top section. So if I simulate, you can see he will now jump off of the edge. So, this gets a lot harder when you want to get them to jump up, to get them to go up this section here. Now, I'm not going to build this, but I will show it in the screen and I'll make these slides available in the chat. So I'm just going to present. But this is called a smart nav link proxy. And this is the code that I usually use. So what we do is so all of the details are here, but I create so you can pick an event, and I'll show you how to get the event. But what I'm doing here is basically just figuring out the velocity that is required to jump from one location to another location, and how long I want them to jump. And that jump is going to denote how high you jump, basically. If you say you want someone to jump 2 foot and you want it to be over 10 seconds, they'll leap in the air for 10 seconds and then land 10 seconds later. And then this is the setup of how you would get it to run. What you're fundamentally doing is you're making the character jump. But before you're going into it, you're calculating the velocity so that they hit the location that you want them to get to. Sorry, Eric?
Okay, so what happens if the distance is too big?
Well, theoretically, if it's the maths, your problem really is there something in the way? If the distance is too big, it's going to launch it in an incredible rate towards that thing like a cannonball at this point. So you might not want to use this. The other option, and it's probably something that we should do in a lab or something, is to play around with ideas, is to create a spline and use that as a method of guiding the movement and force animations to play when you're on that spline. So if you if you want someone to climb a wall, there are a number of different options, but I would probably look at using a spline and playing and using like the state machine to traverse into a climbing animation when you hit the wall, move up the wall, and then play a getting off animation at the end of the state machine. So that would be probably how I would look at approaching it, but I would use a spline for wall climbing.
And will you deactivate gravity from the object that is escalating, or it will not jitter?
Whilst you're using a spline, or
yes. So if the character is climbing or doing this movement upwards, if the gravity still applies to him, he will jitter a little bit because he will be trying to go up, but gravity will push him down.
Well, you can programmatically turn off gravity, but my experience of doing is it doesn't usually.
It doesn't make any jitter?
I'd have to give it a go. It's not something I've done in a while. But yeah, that's Elena. Did you had a question? Sorry, I'm just sort of vaguely aware of.
Yes, this blueprint that you are showing us right now, we are putting on the Navlink blueprint, or we can put it on the level blueprint. And I have a general question. Whenever do I know if I have to use the level blueprint from some interactors, or particularly some blueprint of Nacto?
Okay, so that's a slightly bigger question, but the level blueprint should be used if there is code which is specific to the level. So say you had a sequence, like you wanted a mountain to collapse or something, and you programmed it into a sequence that would be triggered by a collision box. That's something that's good to go on the level blueprint. So specific stuff to a level. With a smart nav link proxy, this is something that you could have hundreds of in your level, and so you don't want to write that in for every single one inside a level blueprint. You want the code to be on the actor, because the actor is where you're going to be telling the things to do stuff. So I would put this code within the link proxy, because this is an actor. And I'll show you where it goes. So this is, if I was to jump into this actor, I think you need to turn on the smart link. Smart link is relevant, is in here. And then we have an event here on smart link reached. So at that point, I can either bind an event to it, or I could just use this as a straight event. So when they reach this, I would then be able to add that code in. So you can see the code here. So event smart link reached. So this is just a piece of code which will trigger at the point that you hit that link. Now, this is just a suggestion of the code that I usually use, because it's quite a nice calculation to figure out how far they have to jump. But you could control it in other ways. But the primary logic is when they reach the proxy, they need to know they need to know that they need to jump, because the AI in itself does not know. It will just walk into that wall continuously, thinking that it will be able to get up there without it. Splines are a lot more consistent because you can force the movement and you can control it. But this is another sort of another method of doing it. This looks more natural. Does that make sense?
Yes. Okay, so if I want this object to trigger the sequence, I will use it as a reference in the level sequence. For example, if I want the actor to just prompt on this nav link and trigger the sequence, I will call it on a reference in the level blueprint.
If you're controlling them via a sequence, you probably wouldn't want to be using something like this, because you'd be able to key in the actual jumping into a sequence. Sequence is about keying very specific movements of things. If you're using a sequence for movement, then this is, and it makes very legitimate sense. Like I think the rail shooter uses a sequence for a lot of the movement stuff. When we're talking about AI, we're talking about generating a logic so that the characters are capable of working on their own, where in a sequence, we are pre-denoting all of the movements, and we might be triggering it from somewhere else. But this is about generating the characters that can look at the world and figure out how they want to move. Does that make sense? The two aren't easily compatible.
Yes, understood. Thank you very much. Thank you.
No problem. Okay. So we've got 15 minutes, so I'm just gonna go through the basics, but we can always cover more stuff when we jump in here. But don't die on me. So it's useful to know that a Navlix proxy is how you connect these elements up. Unfortunately, this has died. Can you still? No, it's dead, so it's back. Okay, so we covered Navlix proxies. We can't go over the code in the time that we've got. Let's talk about making this dynamic. So if I was to let me add in a cube. So I'm going to add in a cube and I'm going to put physics on it. So I'm going to simulate physics and make it movable. We'll add a few cubes in, I think. Okay, so at the moment, if I drop this, the cubes, even though they're here, he's going to be unaware of them. So he's not going to the nav mesh isn't updating, so he won't walk around the cube. So if something blocks his path, he's just going to walk into it and continue walking into it. So how do we get it? So if we want the nav mesh to update, the first thing that we can do is come into project settings. So if we come up to project settings and under runtime generation, so you'll see this under navigation mesh, we've got an option for runtime generation, and I can make that dynamic. There is an option for modifiers only. In this way, you can set specific items to change the mesh, but with dynamic, it will make everything change, update the nav mesh. Now, there is a cost with this, and there are optimizations, so you can change the frequency of the cost change and other different elements. But if we were to change this, you will now see that the nav mesh will adapt to these. And as I move them around, you get this red. That means this section is costly, but you will update the nav mesh accordingly. Okay.
What would be a real life example of something like this that could be useful? If you have a platform that move around or something like this?
Yeah, I mean, a lot of things, sort of rubble, if you smash something up, platforms, anything where yeah, so moving platforms, so conveyor belt. I mean, I'm having trouble thinking of things now, but rubble is my big one. If you've got something where a load of rubble smashes down, and in order to get past it, they have to attack it or something to smash it out of the way. But or
For
Yes.
Danny, I think
Yes.
it's perfect for him, right?
pardon?
For Daniel, for Daniel's games, yours is the one that is the changing
Yeah.
platforms.
I have a good example. My game will be like this part. I'm listening very careful because that's what I needed for my game. Yeah, I think another case is doors. So, for example, if AI don't know like was the door is open or no, so as soon as we open the door, we can update the nav mesh so AI can come through it. Just in like example, I think. Yeah, I had a question. So this nav mesh, it's applicable to all AIs in scene, or we can separate, so separate AIs can use separate nav mesh. For example, like, I don't know, some monsters can go through lava and some monsters can go through lava, and we have separate nav meshes for them, or it's only one nav mesh but different rules for it. How it's applied?
You can have separate nav meshes because you can do stuff like you can change the size. So some like you can do things like height variation. So you can have a nav mesh for very short things and that can go under stuff, or you can have nav mesh for very big things. I've never done it, but I would be interested to play with it. So if you want to, I'll sit there and figure it out with you when we get sort of time in the lab or something. But yeah, there is a setup for multiple nav meshes. So you could have creatures that can move through lava and creatures that can't. But yeah, especially because you get characters of different widths, and you can see here that if you've got a very, very small gap, some characters might be able to fit through it, and some characters might not be able to. So yeah, you can assign a nav mesh, and you can have multiple different nav meshes to think. I've never done it though. So I would be interested to play with it because I know it's possible. I've just not done it.
And sorry, I have two related questions for this, if it is okay. First one, is it possible to set up offset? So, for example, we have an object, and I see that like a nav mesh has some distance from this object. So, is it possible to set specific offsets? So, for example, I need like 50 units around each object. Like so, characters in AI are not coming too close to objects we have that are sticking through the nav mesh. And the second part, is this nav mesh applicable only to AI characters, or player character also affected?
Well, the player character will run off collisions. So
Okay.
nav mesh doesn't, unless you are using the like. There's a say you've got a top down where you point to where to go, and then the character walks to that point. You would use a nav mesh for something like that. But if you're using the third person, it works off just world collisions. You don't need a nav mesh at all if you're in that situation. But yeah, so if you're using like an RTS or anything where you've got that controller, it's still going to use a nav mesh for navigation. Settings for nav mesh. So if I jump into navigation, so you've got a number of different options here. There's resolution. So you've got nav mesh origin offset and engine navigation system. Yeah, so we've got options, stuff like navigation invoker. So a navigation invoker is a component you can add to a actor, which will only generate navigation around the invoker. We've got yeah, a number of different. So there are just some general settings here. Sort navigation by cost area. Yeah, I'd have to look into it more to answer some of these questions, but yeah, I'm just going to carry on because I'm aware we're going to need to jump. And there are only a couple of points that I want to hit from here. I will throw this into chat. but yeah, so there's changing the nav mesh refresh rate is a good way to change the optimization of it. So if you make it in real time, it can be quite costly as it sits there, but it would be very accurate. Navigation invokers. So these are a component that you can add to thing, and then you could use that for navigation instead. The avoidance systems. Now, this doesn't work. Okay. I've got a better way of doing that. I think I've got the movable GIFs in 1 second. Document, no, courses, see, course creation, intro to navigation. It's empty. Okay, so we have, I'm going to try and demonstrate this here by just creating a ton of different meshes. So I'm just going to grab out a whole load of these. Okay. And so now if I push play, half of them are doing nothing. Stop, play again. Stop. Just going to grab all of them. I think they want to be on the floor. Let's try that. Okay, so this is a little bit harder to tell because I did have some GIFs, but what I'm trying to do is you've got 3 different options when it comes to avoidance. So at the moment, this is the default avoidance that they've got. You can see that you get these clumps of people that are stuck together and they can't, this guy in the middle here, for example, can't get out. These are just stuck. They're all sort of walking around stuff. This is the basic avoidance. It's really cheap, but you'll find that it's not very functional, basically. So that is the standard avoidance. Now, if we look at the AI, and we jump onto, I think it's the character movement, we've got an option to use something that's called use RVO avoidance. Now, how this works, I now play the same thing, is whenever any of the characters get close to each other, they have a slight push. They push away from each other. And this works a lot better. There's going to be a lot less people stuck. They're going to be moving quite well. However, you will see a lot of people slide in kind of weird directions as they get close to each other. So it doesn't create a particularly sort of realistic thing. I think this is the point of contention. You can see just people sliding to the left and right. That's because the other AIs are just pushing them off in different directions. So that is RVO avoidance. Now, the final one we've got, we need to actually reparent I think we need to reparent the AI, or is it the, let me just find it. So if I type in crowd, yeah, so there is a Detour Crowd AI controller. Now this is more costly, but it requires us to change the AI controller on this. So if I search for AI, you can see that we're using the standard AI controller. If I change this to the Detour Crowd AI controller, and I'm going to turn RVO off. It is off, okay. Compile, save. Now this is a lot smarter because it's sitting there constantly trying to figure out a new path of the best way to move around. But you can see that we've now got some epileptic people here. So it generally, and you can play around with the settings to make this slightly better, it generally works quite well on large crowds, but it's sort of, what it's doing is it's predicting the path over a much smaller distance. So if everything around it is moving, it's updating, it's going to change the path very, very quickly. Okay, so those out of the box are your 3 different choices. We can see we've still got a bunch of people stuck here by the looks of it. And but we got a lot less people stuck. So when it comes to avoidance, those are your 3 options out of the box. Okay. Eric, you had a question? If we go quick and then we'll jump into the...
Yes. Okay, so if I understood correctly, each agent is taking their own decisions, right? Based on their own data. So it's possible to have like a controller that has the data of each agent, and that controller is the one taking decisions over the little ones?
So at the moment, yeah, every actor has its own controller, and it's predicting its movement and place from individually unaware of what the other ones are doing. If what you're talking about is as like a formation setup where different characters are sort of aware of where the next person is moving to, the crowd system has a little bit of that.
Okay.
But mostly you would need to write that from scratch. My usual way of doing that is you have a sort of predictor object which has no collisions but does a lot of the trying to figure out where it should be, and it's aware of where all the other predictor objects are.
Okay.
And that way it will pick its path and pick its location it's going to move to based on all of the other characters' predictor objects. And that's the closest, the cheapest I could get to from it. There are sort of other methods, but it's quite a difficult thing to set up.
Okay.
But it is something we can play with in labs if you've got the necessity for that. Okay, I'll catch you in the lab, guys. Everyone.